Hello everyone and welcome back again. I'm very grateful to have you back. So in this video, we are going to conduct another data analysis. But for this video, we are going to use a dataset that was obtained from Superstore. Under this analysis, we are going to analyze the sales trends. Also, we will do a shipping analysis, a geographical analysis, products and product category analysis. I'm very glad to have you back. So stick around as we analyze each and every of these categories. Don't forget to subscribe, and I'll be glad to guide you all through. As for my case, I'm using a Jupyter notebook. So let's jump right in. As usual, we are going to start by importing our Python libraries. So I'll be using comments all along to be able to guide you in whatever steps I'm going to take while writing those lines of code. So in this case, I'm going to use pandas, numpy, and matplotlib. I'll start by importing pandas. So pandas import pandas as pd. The next one is numpy, so import numpy as np. As for visualization, I'm going to use matplotlib. So again, I'm going to import matplotlib pyplots as plt. When you run this cell, now you have imported your libraries. These libraries are very important while doing your data analysis. After importing our libraries, we can then move on to importing our CSV file. For the CSV file, you first need to know where you have saved your CSV files, because it's very important, because you are going to copy that file path into our environment. I'm using a Jupyter notebook. And while importing your CSV file, you're going to use the pd.read CSV function, which is an inbuilt function in pd.read, then an underscore CSV, then the brackets. So inside the brackets, that's where we are going to paste the path of our CSV file, which is already saved in our desktop. Mine is on a folder data analysis folder, and this is the folder containing my dataset. So inside the folder, when you look at the type of the file, both are Excel files, but I'm going to use the comma separated values, which represent the CSV file. So when I click on this, I'm just going to click up here to copy this file path and go back to my environment. Inside the quotation marks, I'm going to copy my file. As you can see, this represents my file path, and the Superstore sales dataset represents the name of the file, of the CSV file. So to end this, you need to end with the suffix CSV. And remember, before the start of the quotation mark, you put an R. This is very, very important. So with this, I'm going to save my file in a variable. I'll name my variable as df, just a short name, simple, a short form of data frame. So the importance of using a variable like df in this case, because whenever you want to recall your data frame, your data set, anywhere while you are doing the analysis, it's very easy. You just type in the name of your data set, and it returns your data set. So after this, I'm going to print out a snippet of my data set. So I'll use the the head function df. So df just represents the name of the variable that contains the dataset. So then head. So when you do this, we're just going to print out a sample. Oops, getting an error. Oh, I've forgotten to copy. Cut. After copying the file path, I'll introduce an R here. The main reason why I'm using the R is because inside my file path, I'm using the backslashes. These backslashes will be treated as characters rather than an escape character in my file path, because my file path is contained in a folder inside a folder. So the backslashes are used to separate those tiny folders before you reach to the exact folder containing your dataset. So for my dataset, Superstore datasets is the last folder that contains the dataset. So inside after the Superstore sales dataset, we're going to put another backslash, and inside the backslash, we are going to copy the name of our dataset. So mine is the train. So I'll just copy, then go back and paste it at the end here. Then after this, I'm going to use a suffix, which is the .csv suffix, which is .csv to denote the type of my file. After this, I'm going to use the df.head to print out a snippet of my file. So df just represents my earlier variable that is storing the file, right? So df.head, so the head method, or you can otherwise call it a function, is used to display the first few rows of the data frame. Often mostly they are the first 5 rows of your data frame. But inside the brackets, you can either use, let's say, put a number 7, 10, whatever number you want, and it will print the number of rows according to the number according to the parameter you have used inside the brackets. So by default, it's just 5. Then after this, when I run this, as you can see, it prints out the first 5 rows of my data frame. Indexing in Python usually start from 0. So ideally, the first column here is the indexing. So as you can see, this is a sample view of the data frame that we are going to use. After importing our libraries, so I just forgot, and let me include here what I've been doing in this cell. So here we have been importing the CSV file. So after importing the CSV file, then we move on to maybe having a brief overview of our data. So in Python, there are many options to do this, but the most commonly used method is the info method. So I just call my variable, then info, say, put on the brackets. So this one, we can say that we are having so I'm going to use the info method. So when I call this function, it's going to print out some general results for our data. As you can see, we are having a total of 18 columns. Our data set contains different types of data types. As you can see, we have integers in the column row ID, from order ID to state. These are objects, these are strings, and from the postal code is a float 64. This float 64 represents a float data type. As you can see, region, product ID, all of these are strings, and the cells represent it's also a float. Okay. Now, so this is just a general overview of our data, the one that we are going to analyze. And there's something I need to inform you about before I move on to the next section. As you can see, the postal code has 97 and 89 values inside the column, which is a little bit different from the other rows. So basically, the postal code maybe I won't be using so much in this analysis, but I can show you a little bit how we can supply values into the empty columns, so that maybe we have a similar counts as the rest of the columns. So this is the postal code. So we are missing some values in this column. Maybe there was some error in terms of filling in those values, and because this is not a very important, it won't be a very important column in our analysis, so we can just fill those columns with 0. So to do this in Python, so let me use first comment here. We are going to fill zeros into those empty cells. So again, I'm going to use this function, so df So after writing this, I'm going to use the fill na method, which is a function in pandas that is used in data manipulation and cleaning, particularly in pandas, to fill or replace the missing values in a data frame or a series. So I'm going to, as I said earlier, I'm going to fill those empty spaces with zeros. So I'm going to use the fill na function. Inside the brackets, I'm going to pass in arguments. So I'll use 0 as my first argument. Then I'm going to use the in place true. When I supply the in place equals true, it means that it is going to modify the original series, the data frame in place, and the missing values would be filled with zeros directly in the original data frame. That means I'm not going to change my original data frame. Also, another thing, I want to combine two things. Another thing is that, as you see in my dataset, a float is a number that has a decimal place. But as you can see in the postal code, these numbers don't have decimal places. So I want to convert from a float to an integer. So I'm going to combine, instead of going to another set, so I'm just going to combine those two code snippets and change instead of float to an integer. Then use the asType method. The asType is just is a function that is used to convert from one data type to another. So inside the brackets in the asType method, you pass in the data type you want to convert to. So mine is from float. I want to convert it to integers. So I'll say int to represent the integer. Then after doing this, I'm just going to use the info method to just print a summary again. So by doing this, I'm just saving time instead of. So when I call this and run the cell, I'm supposed to use info. Sorry for the wrong spelling. So when I run this again, as you can see, I've converted. The first thing was to equalize the number of values in every rows. So as you can see, the postal code from 9789 values, we have now increased the value count to 9,800, similar to other rows. And also, this was a float. We have also changed that to an integer, as you can see, int 32. So that is basically how you can do this, changing a value type from a float to integer, or you might also change from integer to a string, depending on what is viable at the moment. So after doing this, we can then move on to another method in Python in pandas, the describe function. Describe method is used to generate descriptive statistics of your data within the data frame. By doing this, it's going to provide some valuable insights into the distribution and the summary of the numeric columns in your data. So when I run this cell, I get this type of output. So as you can see, as I said earlier, the describe is just going to print an output only if your column contains numeric values. So count just represents the number of null values in each numerical column. The mean gives you the mean after summing the values in the column and dividing by the count to give you the mean. This is the standard deviation, gives you the deviation from the mean, above and below the mean. The mean represents the minimum and the maximum, provide the minimum and maximum values in each numeric column. The 25th, 50th, and 75th percentiles. This represents the values below which a given percentage of the data falls. At first, data cleaning is a very crucial step in data analysis process because it involves identifying and correcting the errors, the inconsistencies, and also the inaccuracies in any given data set. It's not only on this, probably in any data set you're going to work on, you need to correct the errors. It's very important as the quality of the data directly affects the reliability and the accuracy of the analysis and the insights that will mostly be derived from your data. The primary objectives in data cleaning involves the handling of missing data, as we did earlier. Also removing duplicates, we look into that. Standardizing the data. Also correcting errors. Another way of cleaning our data is also filtering irrelevant data, and also maybe dealing with spelling and formatting issues in our data. We want to be very precise, we want to be very accurate and very reliable while analyzing our data, because data analysis is a very important factor in decision making. Because I've already tackled some two ways of data cleaning, I'm just going to maybe check for one which is also very important, and that is duplicates. So there are various ways and means of checking for duplicates. At first, I'm going to check if my data frame contains duplicates. So there are various ways to check this. In my previous video, I used the if-else statement. So I'm going to use the conditional statement in this state, I'm going to use the if else. So in my statement, I'm going by this: if my data frame df contains duplicates, so duplicated, and the sum of those duplicates is greater than 0, print out a statement saying that duplicates are present in my data frame. Else, if there are no duplicates, so else, you print out a statement saying that there are no duplicates in the data frame. So I'm going to run this cell. Now the outcomes, the output from this code say that no duplicates exist. That means my data frame does not contain any duplicate. So the other method while checking for duplicates is the df duplicated method. This method returns a Boolean output, either true or false. So it scans through every row in your dataset and checks if they are duplicates, and prints are true if they are duplicates and are false if there are no duplicates. So I'm going to use that one again. So the output from using this method is that it gives you the first 5 rows in the column and the last 5 rows in your data frame. Again, in most cases, this method is quite difficult, because what if the duplicated rows are in column 1000, which is not visible at this case? So it's very difficult to use this method. The first method is quite simpler to use, but you are writing many lines of code. So in pandas, there's another simpler method that you can use, and this is the method we'll be using going forward, unless there's another one that is maybe quite simpler than that. What the method does is that it will give you a count of all duplicated rows in a data frame. This one is simpler, and you just use one line of code while checking for duplicates. So I'm going to use that one. So df dot duplicated, but inside the brackets. So inside the brackets, I'm going to use an argument or a parameter, which is keep false, keep equals false. The keep parameter is used to specify how to handle the duplicates. And when I say keep and keep equals false, all the occurrences of a duplicate row are marked as duplicates, including the first occurrence. So I'm going to pass in I'm going to pass in the argument. So keep equals false. And I'm going to use the sum method. So the first part of the line of code, it will print out a Boolean value. And as we know, a Boolean value is either true or false. So it will either return a true or false for each row, indicating whether it is a duplicate or not. So what sum function does is that it counts all of the true values, which represents the total count of the duplicate rows. All right. So when I print out this, find out that it is 0. So this simply shows or highlights that our data frame does not contain any duplicates. So from these 3 methods, you can maybe decide which method you can use. So I saw it fit to maybe highlight them for you, so that maybe you can pick whatever method is simpler for you, or whatever method you can easily remember. As for me, as I said earlier, I'm going to choose the 3rd method because it's simpler, very easy to remember than the first 2. So because our data contains no duplicates, we can then move on. So since this is a Superstore sales analysis, probably the first thing we can check is customer analysis. We can start by customer analysis. We're going to first highlight to start by checking for the type of customers. And most of the time I'll be calling my data frame. So for customer segmentation, we are going to target, let me print the first three to make it shorter. So for customer segmentation, we are going to target the segment column. In my CSV file, we have the row ID, order date, the ship date. So basically what I'm targeting is the type of customers that are present in that shop in the Superstore. As you can see, we have the consumer, we have the corporate, we also have the home office. So definitely there are different type of customers that the Superstore serves. So we are going to group them and possibly learn 1, 2, 3 things about the type of customers we have. So the first thing, I'm going to target the segment column, and I'm going to first let us know what types of customers we have in this data set. While naming your variables, it's very important to use descriptive names so that it's easier to follow through while assessing your analysis, or even if someone else is going through your work, it's very easier for them to follow through to discover what you are doing. So after creating my data frame, inside the square brackets, I'm going to target this column and pass in as my argument. And outside this square brackets, I'm going to call a function the .unique function. This is the function that is going to count the unique values in the column segment. So unique. Use letters. Unique. All right. So after this, you print out your variable. So we're just going to copy this and pass in as our parameter or our argument inside the print function. So after we print this and call out this function, and run this cell, you can see that we only have 3 types of customers. These are the 3 types of customers that are being served by the Superstore. So from this, we can move on to count the number of customers in each segment. So we are going to count the number of customers in who fall under consumers, and also for the number of customers under the name corporate, and the number of consumers under the home office. So I'm going to just go to the next cell, and while determining the number of customers in each segment, so I'm going to use another new variable. So I'll call my variable as number of customers. And inside the brackets, I'm going again to use the same column as I did earlier. So I'm going to use the same column, and outside the square brackets, I'm going to use the value counts and the reset index functions. So value counts and the reset index. So let me explain what the value counts. So I was supposed to include a full stop after the end of the closing square bracket. So the value count, this is a method that that counts the unique occurrences of values in the series. So as I said earlier, the column segment contains consumer, corporate, and home office as unique values. So the value count will count these occurrences as, and it will return a new series with unique values as the index and the corresponding counts as the values. So the reset index will reset the index of the data frame depending on the number of unique values that are present in that column. So after this, we basically going to print the newly formed series of columns. So we print, as you can see, we have printed out a new series, and this series contains two columns, the index and the segment column. So now we can see that consumer, as the type of customer, we have 5,101 consumers, and we have 2,953 corporate as corporate customers, and we have 1,746 home office customers that are being serviced by this Superstore. So you might want to rename these columns so that it makes it easy to call them while you are performing other operations. So to perform this operation, we are going to rename our columns, and we can just, before we print out this new series, we are going to rename the series and print it out. So I'm just, after the first line of code, we are going to go to another line, and in this line we are going to use the rename function to change the names of the columns in our new series. So inside this variable, so the variable, and use the rename function, and inside this rename function we are going to pass in arguments using a set. Since we're going to change the column, so we pass in an argument as columns, and use a set. So inside this set, we are going to first call the name of the column we want to change in the new data set. So in this case, index. So we're going to first call it and pass in the new name of the column. So we are going to say, we are going to use the name customer type. Again, the next column is segment. We are going to change it to the total number of customers. So again, segment. When we run this code again, we'll see that we have changed the names of the column, so it is very easier to move forward. So for this, we may plot a pie chart for this case, so that we can be able to correctly visualize the distribution of clients, or the type of customers we have in the Superstore. This variable will be very useful for us, because we'll be referencing back this variable while plotting our pie chart. So since I'm just going to use the shorter means of plotting the pie chart in this case. So while plotting a pie chart, we are going to use matplotlib. That's why we imported it as our library. So earlier on, we say that we are importing matplotlib as PLT. So whenever you recall PLT, you will be referencing to the matplotlib library. So for this case, pie. Now in this case refers to the pie chart. Pie chart, bar graph. Bar with an H, it will be a horizontal bar graph. So plt.py. So this, we are now plotting our figure. So as I said earlier, it's very important we'll be recalling our variable because it is storing our keys, our data values. So we need to set our access. So in this case, the numeric values are the total customer. So we will copy this and pass in. Again, see, a pie chart is not like a bar graph where you have the x and the y axis. So a pie chart, you have the values and the labels. So for the labels, so we use the keyword labels. And for the labels, we're just going to use the same. We are going to, again, you copy our original data variable where our keys, our data values are stored. Then you just record it. And you pass in a parameter. And the parameter will be the customer type again. So our labels will be drawn from the customer type. Again, for this, we are going to use maybe different colors to show different types of customers. We are going to display the percentages on the pie chart. So we are going to use this parameter. This is just a formatted string, which is regarded as a placeholder that will be replaced by the actual percentages values that will be rounded off to one decimal place, followed by the percent symbol as we have used it here. So when you run that cell, this is the result. As you can see, this is our pie chart containing the title distribution of outcomes as we showed earlier. And from this analysis, you can see that 52.1% represents our consumer base. Corporate, we are servicing 30.1% of the corporate and 17.8% of home office. So this is just a quick visualization of our data up here. So what we are going to target in this case, we have the column segment, which will first group this the customers according to the respective groups, and we are going to use the column sets. We are going to target two columns. We are going to use the group by method. So here, inside the brackets, we are going to group by the segment. We are going to group by the segment column. So I'm just going to pass in. I'm going to pass that in as an argument segment. So the cells, I'm going to directly sum the cells. So also again, what I'm going, since I showed you earlier how we can directly change the names of the columns. So again, I'm going to directly pass in parameters and arguments that are going to directly change the names of the columns. So right, this is the new series that we have created from the cells and segment columns. We are going to plot another pie chart for this case. So for this case, I'll fast forward because we are just repeating the same thing. This is the new pie chart. From this, again, as you can see, this represents the sales per customer category. So consumers represents the most valuable customer, followed by the corporate and the home office. Again, this is for this case, we can also plot a bar graph to represent to visualize this data. Since this is just a learning exercise, again, you can just choose which visualization method is good for you. Again, you recall PLT, then this is a bar graph, then instead of pi we use a bar, then we recall our variable that contains our information. When you run this, you get the bar graph. You can see our bar graph is well labeled, and this is just similar to what we saw earlier. Again, that consumer base is our most profitable customer, followed by corporate customer and the home office. The customer loyalty section, by this we are going to examine who are our repeat purchase behaviors of our individual customers. So I'll first group the data by customer ID and maybe the customer name, but if you have the customer ID, you don't need to use the customer name, but for the purposes of this example, I'm going to use both and the segments. So to know if they are consumers or home office or corporate, and count how the orders for each customer. So I'll start by that one. So I'm using the variable customer order. Let's say frequency. Then remember, while grouping two or more columns, we use the group by function. And pass in the columns. Then, as I said, we are going to calculate the frequency. Then in another, we are going to order by ID. We are going to count the number of orders they requested from the Superstore. And count them. Also, we are going to reset the index. So from this, as you can see, we have the customer ID, the customer name, the segment, and the order ID. We can rename the order ID column to represent the total orders that instead of order ID, this column should represent the total orders that each customer requested. To make things simpler, since we are just recalling back our variable, we're just going to pass in the rename function directly instead of using another variable. So rename. When we again print this, when we run this, sorry, I just change this. When we run this, you can see that we have now changed our column to represent total orders by each customer. Again, because we have mixed up, we may want to know who is our best customer. By this, we might find it hard to rank our customers. So the best way is to reorder this so that we know who is our best customer. So we are going to reorder this, and by doing so, we are going to identify the customers who have a higher order frequency. I'm passing in the column that we are going to use while ranking. We are going to use the last column, which is the total orders. We are going to use this column, and the total orders should be greater than 1, should be greater, or we are using the greater or equal to 1. So we need to sort this, to sort the repeat columns in descending order based on the order of frequency. So I'm just going again to recall this. Because this code and the one I'm going to type in to use here work hand in hand. So we are going to use the sort function. So inside the brackets, we are going to pass in an argument, and this argument should reference the type of the column that we are going to target, and pass in another argument by which order. So ascending. By default, we usually use the ascending order, but by this line of code, what I'm doing is I'm reversing that order. When we print this, since we have many customers, as you can see in our list, we have about 792. It won't be viable to show all customers. So we are just going to print the first 10 customers. So by doing that, we're just going, in our print function, we are going to pass some key parameters that are going to guide us on this. So the first parameter, I'm going to use this, since I just want the first 10, so I'm going to use the head function, and pass in an argument that I only need the 10. And in this case, we should reset our index. Earlier on, we used the reset index, all right? But here, we are going to drop that index. That's why I'm using the reset index drop true. So we're going to drop the earlier index. So when we run this, as you can see, we now have a new series. The new series contains the customer ID, customer name, segment, and total orders. So by this, it's very easier now to know who are our best customers. We can customer ID. We can now see that William Brown is our best customer, and from the segment, he is a consumer, and you can see the total orders he has made are 35. We can also go further and decide who is our best customer now based on sales. This was what we discussed earlier in terms of customer loyalty. Oops, what we did earlier was the customer loyalty. Who is our best customer in terms of the orders the customer has made? We can now move on to determine the best customer in terms of sales. All right. So again, this is it's another rigorous task as we did earlier. We are first going to group the data based in customer ID, the customer name, and the sales. Now we're going to use the sales column. The other one we use the order ID. From that, we are going to sort the customers based on their total purchases in descending order, as we did earlier. We are going to based on descending order from the customer who has spent more to the least customer, and we are going again to print that out. Also remember we are grouping, we are sorting various columns. So remember we are using the group by. So after this, we are going to sort the customers based on their total sales, but in descending order to identify the top spenders. So it's just like what we did earlier. So, but in this case, I'm just going to use a new variable. I'm going to use the sort values, then pass in my arguments. Again, since we have a long list of customers, I'm just going to prefer the top 10 and reformat the original index. So it's very important to have a basic knowledge about Python so that you are able to explain or understand some of the things that I'm doing. So after doing this, you can cross-check if everything is okay and run the code. So this is the output from our code. As you can see, we have the 3 columns: the customer ID, the customer name, and sales. So earlier on, our best customer in terms of orders was William Brown with total orders of 35. But in terms of sales, our best customer is Sean Miller. You can also pass in the key segment to know if the best, if in terms of sales, who the best customer, if Sean Miller is either a corporate, a consumer, or customer. So to do this, you can just pass it in here, in the earlier here. Then when you run this code, you can see that Sean Miller is from home office. So I think we have done a great deal here. So we can then move on to. So we are going to analyze which mode of shipping is mostly used by the store. So again, I'll recall my data frame. So in the types of in the mode of shipping, we are going to target this column. So we are going to determine the type of shipping modes that are being used by the Superstore while shipping these products to their respective customers. So definitely from the ship mode column, we have the second class, we have the second class, and first class, and possibly many other forms of shipment that are being used by the Superstore. So the first thing that we are going to do, we are just going to record the unique values in the ship mode column, so that we determine how many types of shipping methods are available. So I use this code. So we are sorting unique values in the ship mode column into a new series. So we are using the unique method to scout for the unique values in the shipping mode column and print them out. So when we run this, we find that we have only we have 4. There we have the second class, the standard class, the first class, and the same day method. So from this, we are going to look at the frequency use of the shipping methods. So the frequency use. So I'm going to use another variable. Let's call this variable the shipping mode. So in the shipping mode, we are going to again target the ship mode column, and again we are going to count the values and reset the index. Also, as you know, when we are using this type of code, mostly since we have not supplied the titles of our column, it will rename them to default. So for this case, it will rename to index and ship mode. But I would like to change the index column to mode of shipment and the ship mode to use frequency. We are going to change that. So this is the output. So we have 2 columns, the mode of shipment and the use frequency. As seen from this output, the standard class is mostly used, followed by the second class, which has been used 1902 times, followed by this first class and the same day. So we might plot a pie chart to represent this information. So this is just similar to what we did earlier. So use frequency, we are going to supply the argument use frequency. So this is the representation, as you can see from our analysis, as I described earlier. From this, after knowing the shipping method, maybe a company or the Superstore might want to optimize. So with this information, it is easier for them to know what type of shipping method they are going to optimize. So from our data, you can see that we have the state. So we are trying to know how many customers we have are coming from which state. So again, this is simpler, as it's just as the same thing that we used earlier. So maybe they can just copy this piece of code, all right, and just change the names, so to make it a little bit easier. All right, so instead of using the shipping one, I'm going to use state as my variable. So whenever there is shipping mode in terms of that is being used as a variable, I'm going to replace it with state to make it the value count and the reset index, they just remain the same as I had explained earlier. So instead of the index, so instead of the mode of shipment, I'm going to change the mode of shipment to represent the state. Shipping mode, I'm going to change from the shipping mode. So by doing this, just makes life easier for us. Remember to use the correct variable. So when we run this, we can see that we have 48 states in our analysis, but this is too long. Maybe you can say I want the best 10 states. So instead of printing out everything, we are going to use the head function and pass in an argument, let's say the best 7 states, depending on the number you want. So it would show the best 7 states, that is California. From our analysis from California, we have 1,946 customers, followed by New York, which we have 1,097 customers, followed by Texas, Pennsylvania, Washington, Illinois, and Ohio. So this is just a simple way to group to know which state has more of your customers. So we can move further. You can move further and maybe analyze the customers, but now instead of state, we are going to which city holds the most number of customers. So customer by city. So again, there is no need of changing. I'm just going to copy this code. So as you can see, once you master this, it's very easy because it's just the same code that you are reusing, in that you're just changing the name of the variables. So when you run this, see that New York City is our best city, which having 891 customers. A city from then Los Angeles, 728, Philadelphia, 532. Again, this is quite important. We can also group states. We have grouped states with the number of customers. We can group states and the number of sales from that state. Again, we are going to, since we are targeting more than one column, we are going to use the group by method. So I'm going to use a new variable and pass in the columns. So I was grouping the state and sales while I'm summing the total sales from that city. So I'm going to set based on the in descending order. So inside the brackets, remember we are passing our arguments. Then we print our outcome. So when you run this again, you see that our best sales is our best state in terms of sales is California. Again, we can maybe again determine the sales per state, sales per city, which is also another important measure. So again, we can just recycle our previous code. So when we print this out, we see that in terms of cities, New York City was our best city with sales worth $462,000, followed by Los Angeles, which had $172,420.18, followed by Seattle, San Francisco, and Philadelphia. So by this, we have grouped city by the worth of sales that from the city. Right, now from this we can then move on to product analysis. So I'll begin with the first determining the types of products in our store. The types of products in our store. We are going to target this column. So let me, instead of going up there, let me just recall. So we are going to target the category first. We are going to target the categories of products that are present in our Superstore. So by that, first we're just going to list the major categories of products in the store. And maybe you can use the same to determine the subcategories of the products in the store. So I'll start by the types of categories of products in the store. Again, as you remember earlier, we are using the unique function. So we're just going to produce an output that produces the types of product categories in the store. So maybe we should be more definitive in our variable and introduce and rename this to product category so that we a little bit descriptive. So when we run, again, you see that we are getting the furniture, office supplies, and technology. So these are our major product categories in the store. So moving further, maybe you can use the same code and change the variables and the target column to maybe determine the product subcategories in the Superstore. So maybe that's one of your assignment. You can do that. So maybe you can group the category and the subcategory and determine in each category how many subcategories of products are present in respective categories. So maybe I can show you this. What we are going to do, we are going to group the data of product category and determine how many subcategories are present in each category. So first we are going to group the data by product category. And remember, we are targeting two columns, the category column and the subcategory column. So what type of method while grouping more than one column are you going to use? Up to now, you've now understood that it is the group by method. So again, you're going to use that one. It's true, you've got it. So another way of determining the unique value is using the non-unique function. I usually call it as non-unique function, but while writing is you start with an n, then unique, and also this we are going to reset the index. So just use to recycle the variable. So what function are we going to place after this subcount variable? Do you still remember, since we are sorting our values? Yes, that one, the sort values function. And inside we are going to pass in our arguments. So after this, we are going to print our outcome. For this case, we are not going to change the columns name. We are not going to change the name of the columns simply because we have already supplied in the names of the columns. So we are not going to remember to change this. So we are not going to again change the name of the columns. It will be a worthless task in this case. So for reset, I've forgotten we need to reset the index. So again, when we run this, so we can see that under home office supplies, we have different types of products that are ranked under home supplies. Also in furniture, we have 4 products, and in technology, we have another 4 products. As you can see on the furthest left, the indexing is a little bit disfigured because once we had reset our index and sorted our values, we need to again drop the earlier index to match the new indexing. So to maybe change that, so that to change that index, we are going to reset. Okay, so when we reset our index and print it out, so you know, as you have seen, we now get a new index. Now we know how many subcategories are in each, how many subcategory products are in each category. We can now maybe move on to determine the number of cells per each category. We use a variable category. Then we pass in the names of the columns. Since the cells, you might wonder why I'm pressing the cells column outside. I'm not including the same column with category. This is because under this column, under the cells column, there are further mathematical manipulations that I'm going to carry on that column. That's why I'm not using it inside the same square brackets that have passed category column as my argument. So this I'm going to use outside. So when you run this, you get the 3. As you can see, so under furniture as a product category, the Superstore sold goods worth 728,658.57. And under office supplies, the Superstore sold products worth 705,422. And under technology, as a product category, they sold products 827,455. So maybe we can change this. We sort them in ascending order. So I made an error. So we can just change this. As you can see, that's our result. So we have arranged our categories in ascending order from the most profitable to the least profitable. As you can see, technology leads the rest, followed by furniture and supplies. Maybe you might want to plot a pie chart, just the same thing as we did earlier. So you can just go back and copy this, because we are just repeating the same thing. That's the advantage of using let's say, coding as a way of doing data analysis. Most of the things are just repeatable. Just recycle your code as you move on, making things easier and smooth. When you run this, you get your result. Maybe you might want to know which specific product under the three major categories. So which product under those made the most revenue. For us to perform that operation, we are first going to group the data by product subcategory versus the sales. Then after that, we're going to sort the product category in their descending order. And then we go to print out our results. Then from that, we are going to also plot a bar graph, a horizontal bar graph, to visualize this data. So let us start. So I'll use the short form of product PDT to represent my variable. So product subcategory. Since the sales column is the one we are going to perform the mathematical operations, we are not going to include it inside these brackets. So that one will be outside. So after grouping our data, we are now moving on to sorting that data in descending order. So I am going to use a new variable. So when we run this code, oops, invalid in syntax. So we forgot to add a full stop here. So when I run this, as you can see, there's one thing I forgot. Do you know what I forgot, such that we have a randomized index? Yes, we have forgot to add the reset index. We have not added an argument inside the print function to drop our earlier index. So yeah, we're supposed to add that. So when we run this, we now have a clear output. So from this, we can now see that the best subcategory products we have are phones, because we sold phones worth 782.44. So those are the sales due to phones. Then chairs, we sold chairs worth goods chairs worth 322,822. This is the analysis part. Then there is a report part. I'll also handle the report part of this so that you can see how those reports are usually being presented to your superiors, supervisors, and managers. So I said after doing this, we are going to plot the bar graph. So in this case, instead of using a bar graph, I'm going to use a horizontal bar graph. So while using a horizontal bar graph, the bar, you add a H to represent horizontal, and you can just copy these variables and insert them here. So the x-axis, we are going to use the subcategory column. So we can now show our diagram. This is the output. So as you can see, phones are leading, followed by chairs, storage, that order. But as you can see, our results are starting, our printout, the output, starting from the least to the highest. But maybe it would be wise if phones as a subcategory will be the first item on our y-axis. All right. So to change the sequence of this, we need first to pass a line of code at the top to specify that we are going to change the order of this. Now, instead of fonts to be at the beginning, the fonts should be the last item on the list that we are going to use while plotting this chart. So I'm going to use the same variable, but I'm going to change I'm going to change the order of the items under this variable. So I'm going to sort these values. I'm just sorting by cells. So instead of ascending to be false, just change ascending to be true. So that when we run this, see now we have changed the order of appearance. So again, this chart is, you can use this chart for representing your data. So the last thing that we are going to do is handling things on cells, handling data on cells. So the first thing on cells that we are going to analyze cells in terms of yearly cells. Our order dates column is randomized. So by being randomized, that means it's not properly arranged such that we can simply extract data from that and analyze it directly. So I'm going to group the order dates in terms of years. Then from there we can analyze the cells. In terms of determining the yearly cells, we first have to convert the order date, as you can see, this order date, into a date-time format. A date-time format is essentially used in data analysis and processing because it allows us to represent and work with dates and times in a standardized format. We want to perform an analysis to determine the yearly sales of the Superstore. This data, after sorting through, this data was for the years 2015 to 2018. So those are 4 years. So we are first going to determine the sales, the total number of sales for the 4 years. To convert the order date to date time format, this is the piece of code that I'll be using. The function that I'll be using in this case is the pd to underscore date time. So that's the function that I'll be using. Inside the function, I'll be passing in some very important arguments. The first argument is the order date. Since I'm targeting the order date, this one here, so I'll pass it in as one of my arguments. So order date. Also, I need to specify in the date time. Do I want the day to start, or the month to start, or the year to start? So it's very important to specify which format that you are going to use. So in my case, I'm going to use the format day first. So when converting the date time, the order date to a date time format, it should start with the day, then month, then year. So after converting the order date column into the date time format, the next thing you're going to do is to group the data by years. And after grouping that by years, we are then going to calculate the total sales amounts for each year. The pd.datetime, this is a function that is used to convert dates in a column into the datetime format. So inside the function, I've passed in key arguments, and the arguments are the column that I'm going to target, and I've specified the format of the dates, or the format of the times or the dates that will be in the datetime format. And after doing this, I'm saving that. I'm not changing the column or using a new data frame. I'm just reordering the dates that were in the order dates, but using the new format. So this is not different from what we did earlier, but there's a slight change. So I'm going to provide a variable. So we can say yearly sales. So the dt.year is used to extract the year component from the order date column. So after extracting this, then outside, because we are performing a different set of mathematical manipulation, and we are going to target the sales column, we also pass it in as our argument. We have supplied two key columns, the order date and the sales. And from the order date, we will be extracting the year. So our columns will be renamed order date and sales, which typically they are not representative. They are not representing the data that will be saved under the new series. So we need to first change those names of the columns. And to do so, another thing that you need to remember is we have not used the reset index anywhere. So the first thing we need to do, we need to reset the index. Then we pass in the new names of our columns as arguments. Then we print out our final series. So you can just cross-check to see if everything is okay and print. So this is the output from the analysis. As you can see, our dataset is spanning 2015 to 2018, and it is showing the respective sales that were made for the respective years. So the most sales were made in 2018. So maybe we can visualize this using a bar graph. So we can just copy this and reuse it. I usually call it code recycling. Just recycle codes, the pieces of code. So I just use the same. Also for plotting and visualization, it's very important to have your data in a data format so that to achieve those types of analysis. For the first one, so after this, we are now moving on to grouping. So grouping by year. So when you run this, you get a bar. As you can see, this bar represents the total sales. Perhaps we might rotate the values in our X column so that they may not overlap. So when you want to do that, you might pass another line here. This is 65 degrees, which rotates the labels on the x-axis. When you run that, you can see. So what our data prints out is a bar graph representing the sales beginning from 2015. So this is the 2015 bar, this is the 2016 bar, this is the 2017 bar, and this is the 2018 bar. So instead of a bar graph, we change it slightly to a line graph. And to do that, it's again very simple. We can just recycle the same code, but change a few things. So instead of a bar graph, we use a line graph. Then obviously we will have to change this and possibly pass in other key features. So instead of bar, we are going to use plot to represent the line. Yearly sales, because we are using the same variable, yearly sales, we are not going to change. Yearly sales still remains year, and total sales. But since this is a line graph, we need to include the type of line. Do you want a dash? Do you want it to be a complete line? So we'll pass another argument, marker, and also the line style. So by using the O, this represents a circular marker that will be placed at each data point. So at the point of intersection from the X and Y axis where this value is, it will have a marker. And the line style, I've used dashes, supposed to be 2 dashes. It specifies the style of line that will be connecting the data points from one point to another. So when I run this code, as you can see, we still have the same X and Y axis, and we have the data points. So this is a line graph that represents, you can use it as a trend line that represents the sales from 2015 to 2018. 2018. So maybe if you want a graphical representation, you might use the bar graph, and maybe if you want to analyze the trends, you might use the line graph to easily visualize the trends. Also, what we will do with the quarterly sales is that we will select the year, and from, let's say, 2018 or 2017, depending on the year you want, and determine the quarterly sales in that year. So to begin with, again, we will convert the order date column to the date time format. After that, we filter the data based on the respective year that you have selected. For my case, I have selected the year 2018. So by this line of code, I've filtered the years, but I'm only selecting the year 2018. So I'm filtering from the order date, but the only year I'm selecting is 2018. Then we are going to calculate the quarterly sales for the year 2018. The variable quarterly sales. So I'll provide, while calculating the quarterly sales for the year 2018, I'll use a new variable quarterly sales, and I'll pass in the year sales. But in this case, I'm going to use another function. This function is very important while dealing with data in data time format, and this is the resample function. So here it says .resample. Inside the resample function, I'm going to pass in another important arguments in this case, and these arguments are q, comma, on, at first, the resample method is used to resample the data based on a specific frequency. In this case, Q, which stands for quarterly, because we are analyzing for the quarterly sales for a given year 2018, and the on order date specifies that the sampling is performed based on the order date column. Okay, so and sales, this is used to select the sales column. The sales, as you already know, it selects the sales column of the data frame, while sum is applied to this sales column to calculate the sum of sales in each quarter. So moving ahead, again, remember earlier on we didn't use the reset index because it's very important to reset the index so that our data appears in some defined order. Let's say starting from quarter 1 to the last quarter of the year. So we can pass in an argument such that we print a statement saying that this is the quarterly sales for 2018. So these are the quarterly sales for 2018. Then we print our actual variable. When you run this, again, we have this statement, these are quarterly sales for 2018, and we have two columns. quarter, and total sales. The first row in our column, the first row in our new data sheet is 2018, the third month, the last day of the year. So that represents our first quarter. The second quarter ends on 30th June, the same 2018. The third quarter ends on 30th September 2018, and the last quarter ended on 31st December 2018. And on the column total sales represents the number of sales that were made on each quarter. So you might either use a bar graph to represent the quarters, or for this case, I'm going to use a line graph similar to what I used earlier to represent this data. So I'm going to use plotting a line graph, using a line graph, and I'll just pass in this as my values. This prints out our data, as you can see. So this is the trend of the quarterly sales for the year 2018. So this is how you calculate the quarterly sales for any given year. So this is how you can represent such data. You can also, maybe, if I'm looking for the year 2017, I don't want the year 2018. So if you want the quarterly sales for the year 2017, so this is just simple. What you only change is the year 2017 to represent your year, and by doing that, so after changing the year, you can just run this cell again, and boom, you have your quarterly sales for the year 2017, and you may again print them out. When you run this cell, just use the same variables so it will print out. So this is the representation of the quarterly sales for the year 2017. So with this code, you can just reuse it for whatever year of your analysis. Also, another thing that you might analyze the quarterly sales, then compare the quarterly sales for year 2017, 2018, 2015, and 2016. Maybe that is another thing that we'll carry out in another example, but for the meantime, you can just use this. So I think we have finished with the quarterly sales analysis for the respective years. So for me, I will choose 2018 again to calculate the monthly sales trends for a given year. Also for this case, we are going to copy this. We are going to repeat the same thing, but we'll be changing some details a little bit. So as you know, the first line, we are just converting the order date column to a date time format. So while we are going to, the second thing, we're going to filter the data according to year, the year. Also, we can filter, because you are dealing with monthly sales, we can filter the data according to monthly sales. So again, we can just copy this, because we are just repeating the same thing. But when we move to this step, we are now from the respective year 2018, we are now grouping that data, or sorting that data as per the months in 2018. So instead of Q, because we knew Q represents quarterly, we will use M, which is a key value that represents the months. The order date still remains the same. Sales, because we are targeting the sales column for monthly sales, to determine the monthly sales, it still remains the same, and sum still remains the same. Again, we will rename our columns. So when we press for output, you can see now these are the sales, the monthly sales for the store for the year 2018. And again, I can just recycle this code, paste it here. Instead of monthly sales. So as you can see, these are the trends. So we have reached the end of our practice of how we can conduct data analysis. So we have delved deeper into the analysis. So we started with how we import our libraries, then moved to importing the CSV file. We then moved to the general view of our data. Then we did some cleaning of our data. From there, we moved on to exploratory data analysis, where we analyze the customer analysis. We delved deeper into customer segmentation, customer sales, customer loyalty. We then moved to the mode of shipping, where we analyze which mode of shipping was most used by the Superstore. From there, using we analyzed the data, we used relevant visualization techniques, and we're able to see how we can use them, how we can employ them while analyzing our data. Definitely, when analyzing data, most of the time, different types of data require different types of analysis. It's been a daunting task analyzing this, but at the end, at least we have gotten something out of that. So please subscribe, share, and comment. I would like to hear from you. So until next time, bye bye.